Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So let's see today's daily challenge on Leetcode and try to solve it together. So in today's video, I will show you three methods to solve the problem. Okay, we will start how to exactly think on this problem from very basics, that is from O of m into n. Then we will go to O of n solution. Then I will also tell you a O of 1 solution. Okay, so let's try to see the question and understand what it wants to say at first. Okay, so Alice and Bob playing a flower game. Alice and Bob are playing a turn-based game on a field where with two lanes of flowers between them. There are X flowers in the first lane and Y flowers in the second one. Okay, and the game proceeds as follows. Alice will always take the first turn, and in each turn the player must choose either one of the lane and pick flower from that side. At the end of the current turn, okay, if there are no flowers left at all, it means that the other player cannot pick any flower and the current player captures their opponent and wins the game. Okay, so if it comes a point that the player is not able to pick a flower, then he loses the game. Okay, the other player wins. Okay, so it just means that. And given two numbers n and m, the task is to compute the number of possible pairs x comma y such that there are x flowers in the first lane, y flowers in the second lane, and x should be in the range of 1 to n, y should be in the range of 1 to m. Okay, so you need to return the number of possible pairs x comma y that satisfy the conditions mentioned in the statement. Okay, so if you try to think this at first, you see you have two lanes, you have x flowers in this lane, y flowers in this lane, and Alice starts the game. Okay, Alice starts the game and Bob takes the second turn. Bob takes the second turn as it is told in the question, and Alice must win the game. You need to make Alice win the game. Okay, so it is not told that from which lane Alice will pick, so he can pick from any of the two lanes. Okay, so it doesn't matter which flower, I mean which lane has which how many flowers. All it matters is the total number of flowers, which is x plus y. Okay, so Alice picks first flower, then Bob maybe will pick the second one, Alice pick the third one, and so on. So now the last flower must be picked by Alice in order for Alice to win the game. Okay, so you see Alice starts with this Bob, then again, then Alice, then again Bob, and in this manner you should note that this pattern must end with A. Okay, it must end with A. So I can ask you how many such x, and this, what is the first row denotes? The first row denotes x plus y, right? Total number of flowers. So you can see that if the a pattern ends with A, definitely this value should be an odd number, because you see Alice, in front of Alice there is always an odd number, right? So you see, one thing you try to notice is that one thing you can conclude from this, that x plus y must be an odd number. Okay, so x plus y must be an odd number, and are no further restriction on x and y. Only the thing is that x should be in the range of inclusive 1 to n, and y should be in the range of inclusive 1 to m. Okay, so this is the only constraint that you need right now, and what you can do is very simple. Now a simple brute force approach might be coming to your mind. What is that approach? Okay, so a simple brute force approach which you can think of is that to keep two loops. Okay, for x it should go from x equal to 1 to x equal to n, and you can keep another loop for y equal to 1 to y equal to m. So both of these loops you can just keep an if statement. If x plus y is odd, okay, so is odd, it means that if x plus y modulo 2 is equal to 1, then you do answer plus plus. Okay, you keep a long answer. You see the return type of the answer is long, right? So you can keep a long answer and equals to 0, and you can just keep adding answer 1. Okay, so but you see the constraint are 1e5, so if you try to do it in O of m into n, okay, O of m into n, it will be 1e5 into 1e5, it will be 1e10. Okay, 10 to the power 10, and you know that you must solve in 1e7 at in the worst case. Okay, otherwise your it will give you a TLE. So definitely, although this is a solution, but this is not a feasible solution to write. Okay, because this is okay, way too simple, and I hope you understand this easily. Okay, so the only criteria which we imagined is that x plus y must be odd. Okay, x plus y must be odd. So in order to reduce one of the loops, in order to reduce, let's say I want to reduce, I want to cut short this inner loop into a single statement, what can I write? I can write it in this way, is that I can have just one loop of x going from x equal to 1 to x equal to n. Okay, and you see, when x is odd, y must be even. Okay, and when in order to have the result equal to odd, and I hope you can easily visualize this, why is it so? Okay, and if x is even, then y must be odd, because the whole number is odd, the addition of them is odd. Okay, so if one is even, the other must be odd. So you can keep a statement like, if x is odd, okay, if x is odd, then y must be even. Okay, now you see, y can take the values from 1 to m, right? So if I ask you how many even numbers are there from 1 to m, what will you say? So if you see, if you try to count the number of even numbers in, let's say, a number 7, from 1 to 7. Okay, so you can see there are 2, this is 4, and this is 6. There are 3 even numbers. If you count from 1 to 6, you will still get 2, 4, 6, and 3 even numbers. So you see, uh, why is it happening is that m by 2, you can do m by 2 and floor value. What is the floor value means? It is nothing but an integer division. It just means that I mean 7 by 2 is actually 3.5, right? But in you know that in C++ or in most of the programming languages, it is just 3. Okay, so uh, so we need to do a simple floor division. This is only known as floor division. So I hope you can understand that for even, if x is odd, y must be even, and therefore answer must be added to something like m by 2. Okay, you can just add m by 2 to your answer, because there are 3 occurrences. So I hope you can easily understand that. And when you can see that else, what will happen in else is that I will have an even number right now. Okay, now if x is even, y must be odd. So from 1 to m, how many odd numbers are there? So if you see, from 1 to 7, I will try to count again. From 1 to 7, there are 4 odd numbers. Okay, 1, 3, 5, 7. So 4 odd numbers are there. And in 1 to 6, or in 1 to 8, you count, there is again 4 odd numbers. So can you do 8 by 2 or 7 by 2 right now? If you do this, it will get 3. If you do 8 by 2, you will get 4. But you, both of the case answer is 4. So you will take, instead of a floor value, which you are taking, okay, we will take a seal value. Okay, so if you don't know about floor and seal, I will just tell you. Floor value is of, let's say, 3.9 even, it is 3, because we do not take the point case. Okay, we just chop it off. And for the seal value, even for 3.2, the seal value is 4. It means that go to the ceiling. Okay, so if we represent the seal value in this way and the floor value in this way. Okay, so I just told you. So that's what we are doing in here. So what we can do is that, instead of confusing with this all floor and seal, I can just add 7 plus 1 by 2. And even if I do something like 8 plus 1 by 2, we will be getting 4 both of these cases. Okay, so I hope you can understand this. We need to get 4 from first answer for 7, also for 8 also. So this is what we can do easily. So we can do something like answer plus equals to m plus 1 by 2. Okay, that is what we can do. Okay, so yeah, this will be all. You can see that this will also work in O of n time. There is also a simpler solution, but this will also run because n is 1e5, so we can just try to run and check it. Okay, so let's see, let's have an answer long. Okay, well, let's initialize it to 0 at first, and we will keep a loop x. This x will go from 0 to n, 1 to n. Okay, and this x will keep incrementing itself. And you see that if x is odd, okay, so x module to equal to 1, it means odd, then y must be even, right? And the number of even numbers is nothing but answer plus equals to, you just count the number of even numbers, which is equal to answer plus equals to m by 2. Okay, and else you need the number of odd numbers from 1 to m. Okay, so since it is from 1 to m, you need this. Okay, so I hope you can easily understand this, and if you try to just return your answer, it will also give you the correct answer, I guess. So let's try to run and check if it works, and let's try to submit it now. So you see, we get the 100% runtime complexity even with a single for loop. Okay, so if you want to reduce this for loop, you can see that we are adding this 0 depending on whether x is even or not. We are adding this 1 depending on whether x is even or not. So this whole thing you can write, can't you write it in a single statement, right? You can do something like m plus x module 2 equals to 0. So it means that this whole operation, this whole expression will evaluate to 1 if the statement is true, and it will evaluate to 0 if the statement is false. So I need to add 1 only when this is true, x module 2 equal to 0 in the else part. Okay, so you can just do this and remove the whole thing. Remove this whole thing, and it just means the same thing, right? It just means the same thing. If you try to run and check, okay, you will find that it just means the same thing and it's nothing different. So you can see it will still get 100% runtime complexity even with this statement. But can we do something better? Can we do something better? Definitely. So I hope you have already understood the meaning of seal and floor statements. Okay, seal and floor values, and when and where I am using them, when and where I am going to use them. Okay, so you can see that when from 1 to n, when I am counting from 1 to n, okay, and I want the number of even numbers, I want the number of even numbers, okay, I am using seal value. And if I want the number of odd numbers, I am using okay, for just I told just the opposite. Okay, pardon me for this. This will be floor value. This, for even numbers it is floor, and for odd numbers it is seal. Okay, I hope you understand it. So if we take just an example from 1 to 7, okay, so there are 4 odd numbers and 3 even numbers here, right? So 7 by 2, if you take the seal value, you will get 4, and therefore the odd numbers is seal. And if 7 by 2 you take this floor value, you get 3, and the number of even numbers is denoted by that. Okay, so just you need to now keep in your mind is that this n by 2 we will use a floor value for even, and we will use a seal value for odd. Okay, so if you try to remove even the next loop, what you can do is that, see, you are given m and n, right? You are given n and m, okay, and you want to x to lie between 1 to n and y to lie between 1 to m, and that's what you need to do. So you see, what you want to do is that if x plus y, you need to keep odd. Okay, this must be odd, as I have already proved earlier. So there are two cases here. You know that even plus even, uh, let's say if I consider the parity of x and y separately, even plus even will give you an even number. So this is not the case which we are looking for. This is not the case. Even plus odd will give you an odd number. So this is the case which I am looking for. Odd plus even can give you another odd number, and odd plus odd will also give you an even number. Okay, odd plus odd will also give you an even number, and this is not what I'm looking for. So what I will be looking for is these two statements, even plus odd and odd plus even. So I have only got two cases. If x is odd, y is even. If y is odd, x is even. So that's what I need. And you see, for even numbers, for finding the number of even numbers, we need a floor value, right? So you see, uh, you consider two cases. Case 1, x even, y odd. So for even numbers, as I told you, you need the floor value, right? So what you can write it in this way: n by 2 floor. Okay, number of even numbers, n by 2 floor, and y needs to be from m, and it is the odd value, so you need the steal value here. Okay, and case 2, if you try to think of case 2, it is also very simple. It is simply x is odd and y is even. So you get something like n by 2, you take a floor value for odd and a seal value for m. Okay, seal value for m. Now if you try to you see, you can just look to add all of these. Okay, you can just look to add all of this. So if you try to think that these are the number of cases, so this is not multiplication. If you see, this is independent. So out of all the from 1 to n, this will be multiplication. I hope you can understand this, right? This will have to be multiplication. This is not, because of all the possible x values, these are all the possible x values which x can take, and these are all the possible values which y can take. So how many possible values x plus y can take? So let's say x can take 3 values and y can take 4 values. Then if all are distinct, then you can say that x plus y can take 12 values. Okay, so let's say if, in order to make this more clear, if x1, x2, x3 are the values which x can take, y1, y2, y3, y4 are the values which y can take. So you can compare, combine everything with every other thing, and you can get 3 plus 3 into 4 equals to 12. So that's why there will be a multiplication here. There will be not an addition. So I hope you do get that. I hope you do get that. And what you need to do now is that you simply need to add these things. You just need to add these things. So what will be left when you just add? It will be n by 2 into m by 2 plus n by 2 into m by 2. So now you can just simply print this also. It will be still an O of 1 solution, but I need to simplify this expression, right? I need to, let's try to simplify this expression. So we now n and m, there can be n and m which can be odd or even, and accordingly this will get expanded, right? So if you take the case where n and m both are even, okay, so if they are even, all will be perfectly divisible by 2, and there will be no decimal point, and we will get the exact same number. So if the case where n and m both are even, we are taking the case where n and m both are even, then we will have something like this will just simply get expanded to n by 2 into m by 2 plus n by 2 into m by 2. Okay, so it will give you mn by 4 plus mn by 4, which is nothing but mn by 2. Okay, so mn by 2 is the thing when you have even and even. So when you have one of them to be odd, let's say odd even, let's say odd even. Okay, when you have one of them to be odd, so you can see that um, for this what you need to do is that when you have one of them to be odd, what you can do is that uh, for the odd case, what it is, we need to take the seal value, right? For the odd case, we need to take the seal value. So if n is odd and m is even, m will be perfectly divisible, and m will get I mean m can easily come out of this whatever floor or seal is there. Okay, so you can write it something like this. You can write it something like this. And since m is even, it is perfectly divisible by 2, there is no decimal point, and therefore you can just keep it out. Okay, and for n, if you see, there is a decimal point. Okay, and for a seal, if you are taking a floor value, what does it mean? It simply means that you have something like, if you are taking a floor value of this something which is odd, so let's say odd is 7, and 7 by 2 is actually 3.5, right? But this seal value means 3, so you need to do n minus 1 by 2 for this, and you need to do m by 2 for this. Okay, and in a similar way, for the floor value, you need to do n plus 1 by 2, and you need to do m by 2. Okay, so if you try to take m by 2 common, you will just get n minus 1, n plus 1 by 2, and this one will get cancelled out. This gets cancelled out, and what you will get is I guess I hope you can understand m by 2 into 2n by 2. Okay, so which is also nothing but m into n by 2. Okay, so you see, if one of them is odd, you still get an n into m by 2. And if you try to think further, if both of them are odd, okay, so you will be remaining with something like this. Okay, uh, you try to solve it, you will easily get something like this: n minus 1 if both are odd. Okay, if both are odd, and then the seal value and the floor value will be something like this: by 4 and plus n plus 1 into m minus 1 by 4. Okay, you will get something like this. And if you try to visualize it, if you try to solve it, you will get something like nm plus m minus n and minus 1, and you will also get mn, uh, you get minus n plus m, and you get a minus 1 here also. Okay, so if you just try to root by 2. Okay, so if you see, n m get cancelled out, but you have something like 2 m nm minus 2 by 4. Okay, so you have nm mn minus 1 by 2. Okay, so you see, you take all of these cases, you are either getting nm by 2, or you are getting nm minus 1 by 2. So you see, this 2 means nothing but mn by 2 whole floor value, because I hope you can easily get it. In floor value, we just do minus 1 by 2. Okay, this is what actually floor value means. It means that if you have 7.5, okay, you just if you are just, I mean, not 7.5, if you are doing 7 by 2, and if you are doing it 3, it means that you do 7 minus 1 by 2. Okay, so if it is having n into m by 2 or n into m minus 1 by 2, you are just doing it nothing but floor value. Okay, so I hope you can easily understand this, and this was some mathematics. Okay, I hope you can go through this portion once more, okay, in order to understand this clearly. Otherwise, if you can just take an example and try to visualize how things are going. If you are just thinking the rigorous derivation is difficult for you, it is actually not that difficult. It is just simple high school mathematics. It is not much difficult at all. So whatever be the case, I can just write a simple single L thing. Okay, I can just write one LL, or I will just typecast long. Okay, so I can just typecast long into something like m into n, and I can just reduce it by 2. Okay, so if we try to run this and check if it works, or is there some error, you see we got an accepted thing. If you try to submit it, uh, cannot be represented in type int. Okay, so uh, first it is storing it in integer and then converting to long. Okay, so that is why the difficulty is arising. So instead of this, I think you can just put it in this way. Does it still give you an error? Or is it fine right now? So you will see it is just fine. You just typecast the m to long and then multiply it with n, and it will just work fine. So yeah, I guess this was a simple one-liner problem, but if you want to derive it, you do need to do some mathematics behind it. Okay, I hope I was able to make this very clear to you. If it is not clear, you can still ask me in the comment section, or I will suggest you. I mean, there is nothing that you cannot understand in this problem. Okay, so if you are not able to understand, it means that you have not watched the video that much carefully. Okay, so you can go through this mathematics portion again, or do little bit of pen and paper yourself, and you will easily get it. Okay, so I hope you understood this statement. I understood this problem clearly. So yeah, that was all for this video, and I will meet you in the next video. Till then, thanks a lot.